Hello again. In this video, we're essentially going to be just continuing on from where we left off in video 11, where we introduced the simple rule of differentiation, and we're just going to look at even more complicated examples which you will come across in higher. Before I get into that, I just want to introduce some alternative notation. So in the last video, if we had a function f of x, which was, I don't know, x squared, for example, then we said that deriving this was by writing f prime of x, and that would be 2x in this case. There is alternative notation. If you're just given the expression x squared and you're not given it in function form, then the way that we write that, if we want to differentiate that, is by writing this, d by dx of x squared, and that would equal 2x. So let me just explain what this is. So d by dx reads as you're differentiating x squared with respect to x, okay? And that would equal 2x. If you're given the function in, say y equals x squared, or this could be anything, this could be g equals x squared, h equals x squared, then we would write dy by dx, which is 2x. So that's reading as differentiate y with respect to x, but y is x squared, so that's the same thing as saying differentiate x squared with respect to x, and that would equal 2x. But you could also have, say, like w equals x squared, so differentiating that would be dw by dx, which is saying differentiate w with respect to x, and that would also be 2x. But you see that in all of them, they're all the same answer because you're differentiating the same thing at the end of the day. So here we have an example. We want to take y equals the square root of x and differentiate this. So for all these kind of examples, you're going to want to be intimately familiar with surds and indices rules, or particularly, I suppose, indices rules. And what the idea is that we always want every single x term to be expressed as x to the power of something, and that's it. So it's not dividing, it's not got a root on it, it's got nothing but a power on it. So hopefully we remember from our National 5 Maths that the square root of x is the same as writing x to the power of 1 over 2. And so differentiating that, so dy by dx equals, and we multiply the half, so this is just back to that same rule, x, and 1/2 minus 1 is minus 1/2. And again, if you're not comfortable with that, you can verify that by doing this and then working that out. And this slightly more complicated example, we have 2 over 3 x cubed minus 4 times the fifth root of x cubed, and I want to differentiate this. So again, what we have to do is make sure that every single x term that we're dealing with is strictly expressed as just x to the power of something. So we're going to take this, and here we have x is on the bottom. We do not want x on the bottom, we want it on the top. So I'm going to move x up, and hopefully we remember again that when we move something up or down a fraction, we just flip the sign. So that will become minus 3 from plus 3, and then that will be over 3. Then we will have minus 4 times x, and remember that the bottom number of the fraction represents the root, and the top number is the power, so that will be x to the 3 over 5. Differentiating this, well, first of all, what I'm actually going to do is now write this in a slightly different way. I'm going to write this as 2/3 x to the minus 3, minus, and then the same thing. And the reason why I'm doing that is because that will make it a little easier to split these things up here. So you'll see what I mean. So if I take dy by dx, then when I multiply this minus 3 there, that will be minus 6 over 3 x to the minus 4, right, because we subtract the power, then minus, and then multiplying this, so let's think about that. So 4 times 3/5 is going to be 12/5, right? So we'll have 12/5 x, and then subtracting 1 from this. So imagine that we're just subtracting 5 over 5. So that would be minus 2 over 5 in the end, wouldn't it? But again, you can take it over here if you're not comfortable with that. But we'll have minus 2 over 5. So splitting it up like that, separating it out like that, makes this easier to evaluate. So now we have minus 6 over 3, which is simply 2, and that will be 2x to the minus 4, minus 12/5 can't be simplified, so we'll leave that as 12/5 x to the minus 2 over 5. In this example, we want to differentiate all squared being the square root of x plus 1 over the square root of x. So first of all, again, let's sort of simplify that and make sure that we're getting just x to the powers of. So in here, first of all, actually, because all of this is trapped inside a bracket, I'm going to expand this bracket. So that will end up being this when you square it. Okay, so square root of x times square root of x is just x. Square root of x times 1 over the root x will be root x over root x. Then we'll have this one, which is again root x over root x. Then this one here will be, so that'll be 1 over root x times 1 over root x, which will be 1 over x, right? Because what's happening there is you have 1 times 1, which is 1, then root x times root x on the bottom, which is just x. Now simplifying that, well, that's just x, we can't do anything with that. Root x over root x is 1, and that's also, this is equal to 1, and that's equal to 1, so that'll be 1 plus 1 is 2, and then we have plus 1 over x. And here, 1 over x, I want that to be on the top, the x to be on the top, so I'm going to have x plus 2 plus x to the minus 1, because that's technically to the power of 1 there. And so now we've taken this expression and made it in so-called differentiable form, where it's just x to the power of whatever, and also constants. And so differentiating that, so since it's not expressed as a function or just y, in this case I just have to write d by dx of this thing, which will be x plus 2 plus x to the minus 1. Just make sure to put that in a bracket to say that you're deriving all of it. And that will equal, so derivative of x is actually just 1, derivative of 2 is gone, that's a constant, and derivative of x to the minus 1 will be minus x to the minus 2. In our final example, we have that b equals x plus 3 over 2 times the cube root of x. So again, I have to get this into differentiable form. And the way I'm going to do that is by first writing this as x to the power of 1/3. So we will have x plus 3 over 2x to the 1/3. Now, in similar fashion to how, if I just look at this, for example, 4 over 3 plus 5 over 3, if the denominators are the same, we can combine these and make that 4 plus 5 over 3. We can do the reverse and split it up, okay? So if you have something plus or minus something on the top divided by something, then you can split that up to individual terms. So we're going to have here x over 2x to the 1/3 plus 3 over 2x to the 1/3, and then that allows us to move our x's up to the top. So in this case, actually, because we have x over x, we're going to actually use the subtraction rule. So that will be x to the power of 1, and when we divide, we subtract the powers. So we're going to have 1 minus 1/3, which is 2/3. So we will have x to the 2/3 over 2 plus, and this one doesn't have an x, so I just move the x up, so that will be 3x to the minus 1/3 over 2. And if I just scroll down here, so now differentiating this, well actually, you know what, first of all, let me just pull these constants out to the front. So dividing something by 2 is the same thing as taking half of it. So we'll have x to the 2/3 plus 3 over 2 x to the minus 1/3. And remember that this equals b. So all of this is just b, but we're just rewriting it until we get it into that form that we need, where it's ax to the n, ax to the n. Now, finally, we can differentiate it. So here now we take, so we're differentiating b with respect to x. So we say db by dx equals, right, so 2/3 times 1/2, so the top will multiply the top, bottom times over the bottom, so we'll have 2 times 1, which is 2, over 2 times 3, which is 6, and then x, and subtracting 1 from that power will give us minus 1/3, plus minus 1/3 times this will be So actually I should change this plus to a minus. So that will be minus 3 over 6 x. So minus 1/3 minus 1 will be minus 4/3. And simplifying these numbers, 2 over 6 is the same as 1/3. So that will be 1/3 x to the minus 1/3 minus, and 3 over 6 is 1/2. So that will be 1/2 x to the minus 4/3.